Hello everyone, this is Sri Sankit Uppalapati. Today we'll be presenting our paper, a novel approach for climate classification using agglomerative hierarchical clustering. So what is climate classification? The world's climate is classified into different regions based on their characteristics. There are many such classifications like ASHRAE Standard 169, Köppen classification, etc. using climate parameters like temperature, humidity, solar radiation, etc. In our work, we have developed a novel method for classifying cities based on number of similar days between cities using agglomerative hierarchical clustering. The number of similar days between cities are calculated using daily mean temperature, daily mean relative humidity, and daily mean solar radiation. Here is a flowchart of our methodology divided into three main steps. First step is preparation and extraction of all required input data. Second step is our algorithm where we classify cities. Third step is evaluating the classification and assigning a score. Step 1 is preparation of data. Raw input data is energy plus weather files, which are EPW files. From these files, we extract the following parameters: daily mean dry bulb temperature, daily mean relative humidity, daily mean global horizontal radiation. Therefore, for each city, we have a matrix of 3 columns and 365 rows, where the 3 columns are the 3 parameters mentioned above and 365 rows represent the number of days in a year. We have used a sample building model upon which we have run a simulation to extract sensible cooling, latent cooling, and total heating energy values, which are used for calculation of score and evaluating our classification. Since the labels for classification are not known prior, we are using unsupervised machine learning technique. Unsupervised machine learning techniques are used to discover hidden patterns or data grouping in a given set. In our case, we have used agglomerative hierarchical clustering, which constructs a dendrogram and combines clusters based on the air nearness or similarity for the number of clusters provided. As you can see in step 2, first we provide threshold values for climate parameters V1, V2 and so on till Vn. Then we identify the number of similar days between two cities using maximum bipartite matching. After getting a similarity matrix between all cities, we use agglomerative hierarchical clustering to classify the cities into k number of clusters. Here you can see the process of calculating similarity matrix. This is a sample data of an input file of a city. Rows are days, here number of days are 5. Columns are the climate data of a city named here from A to E. Subcolumns are the climate parameters. Here it is V1 and V2. This is a sample of similarity matrix generated. Each entry represents number of similar days between two cities. You can see it is a diagonally symmetric matrix. We used maximum bipartite matching when calculating the number of similar days because in a maximum bipartite matching, a set of edges is chosen in such a way that no two edges share an endpoint and maximum of such edges are created. Therefore, we can get the maximum value of number of similar days. Spread score. The score is defined by interquartile range or spread, which can be derived from the box plot. The scores are computed based on sensible cooling, latent cooling, and total heating. The total spread score is a summation of 3 individual spread scores. that is spread of latent cooling energy, spread of sensible cooling energy, spread of total heating energy. We ran our classification methodology for US cities. Total 786 cities were analyzed and classified into 16 clusters. 16 clusters were chosen because ASHRAE Standard 169 climate zones are also 16. So from the table you can see for certain combinations of threshold we got a better score than ASHRAE. Here you can see a graph for ASHRAE Standard 169 climate zones and spread for total cooling. This is the spread for our proposed method for sensible cooling and total cooling. These are the results for climate zone map based on ASHRAE 169 and climate zone map based on our proposed method. So from the table in slide 15, you can see that the blessed classification was achieved when the threshold values of 7 degrees centigrade was used for daily mean dry bulb temperature, 45% for the daily mean relative humidity, and 35 watt-hour per meter square for daily mean global horizontal radiation. The findings demonstrate that the proposed method, utilizing number of similarities and scoring techniques, achieves higher score compared to ASHRAE Standard 169. Thank you all for listening. Thank you everyone.